Unit 5 in our class was all about writing linear equations. Most people, when they hear that they need to write a linear equation, they're going to think of y equals mx plus b, which is great. It's a solid go-to when you're writing a linear equation. So let's practice with this graph. This is a graph from the STAR test. So when you look at y equals mx plus b, you know you need the slope and the y-intercept. So looking at this graph, let's start with the slope. I need 2 perfect points. I'm going to go with these 2 right here. So my rise is going to be 2. My run is going to be 8. So my slope, 2 over 8, is really 1/4. So that becomes the m. Then I need the y-intercept. Well, the graph starts right there at 16. So y equals 1/4 x plus 16. Great. Nothing wrong with that. So the next problem would be from a table. And again, most people probably think y equals mx plus b. So they go and they start by finding their slope. Plus 18 down here, plus 6 up here. So I make it into a slope, 18 over 6, which is 3. So y equals 3x plus, and here's where we hit a problem. The next thing we need is the y-intercept, but there is no y-intercept in this table. You may be looking at this thinking that's the y-intercept, but that's the x-intercept, so we can't use that. So because I don't have the y-intercept, I need to use something different. This is where we first introduced the writing equation flowchart, okay? This is the flowchart that we used anytime a problem asks you to write an equation for a linear function. It starts by asking you to find the slope, which is what we did for the last 2 problems. The table, we found the slope. The graph, we found the slope, rise over run. That's always a good starting point no matter what the problem is. But then we have to make a decision. For the graph, we took this left-hand side for our path. We had the y-intercept, so we went straight to y equals mx plus b. But the right-hand side is for a problem like this table. We don't have the y-intercept, so we have to go this other direction. We have to go the direction that says a point. All I have is some points in that table. I don't have a y-intercept, which means I have to use point-slope formula, okay? So let's really fast pause and talk about these different types of equations that we have. For linear functions, we have 3 forms. This middle one, we'll start here, slope-intercept form is y equals mx plus b. That's the one we use the most often. It's the most helpful because it has the slope and it has the y-intercept, okay? But sometimes, like I was just saying, you have to use point-slope form. That's this one on the top. This is where you plug in a point that you've been given to y1 and x1, as well as the slope, and it helps you form slope-intercept form. That's why the next part of this flowchart is going back to y equals mx plus b. The last form is standard form, and this is one that's probably the least helpful because this a, b, and c, they don't mean anything. They don't represent the slope, they don't represent the y-intercept. It's just another format that we use to write a linear equation. We did learn some rules about it. We learned that the a cannot be negative, and we learned that a, b, and c cannot be fractions or decimals. So none of these numbers cannot be fractions or decimals. They all have to be integers, okay? But again, that form is really not that helpful. We almost always take standard form and turn it back into slope-intercept because it allows us to see more. So let's go back up and let's finish out this problem with the table. We just said that we don't have the y-intercept. So instead of me starting with y equals mx plus b, I'm going to start with y minus y1 equals mx minus x1, point slope form. So I'm going to plug in my slope of 3. That was great. I still needed to find that. But now I need to plug in a point. I'm going to just use 233. It doesn't matter. But I'm going to pick that point just because they're both positive. I'm going to plug in my y value, my x value. Going to distribute the 3, and then I'm going to add 33 to both sides. So y equals 3x plus 27. Okay, so I was able to find the equation eventually, but I had to use point-slope form to get there. So here's an example of a STAR question that uses the skills that we learned in Unit 5. It says, what is the equation in slope-intercept form of the line that passes through the point 2, negative 2, and is perpendicular to the line represented by y equals 2/5 x plus 2. Okay, well this brings in one more thing that we haven't talked about, which is what happens to the slopes of parallel and perpendicular lines. So remember that parallel lines have the exact same slope. So if one is 2, the other is 2. If one is negative 3/2, the other is negative 3/2. Perpendicular slopes are opposite reciprocals. So if one of them is positive 2/3, the other is going to be negative 3/2. You flip it and change the sign. So looking at this STAR question, the line that they give us is y equals 2/5 x plus 2. So the flowchart says we start with the slope. Well, if it was 2/5, we want it to be the opposite reciprocal, so -5/2. Okay, so that means that I want to get rid of a and b. But then the flowchart says, again, do you have the y-intercept or do you have a point? When I go back to this problem, a lot of people get confused because they see this y-intercept right here of 2. But that's the y-intercept for that line. We care about this new line that we're creating, and we've been given a point for that line. So I have to, again, use point-slope form because I have not been given the y-intercept. So I'm going to plug in the point they gave me. This one is a -2, so remember, a minus minus makes a positive. The slope we decided on was -5/2. So now I go through the process of distributing and then moving that 2 over. Remember that you do have your calculator available to you to help you do things like multiplying this -5/2. If that weirds you out, your calculator will help you out. And I get a +3 as my y-intercept. So the answer there was D.